So, welcome everyone for today's event, Build with AI, building a multi-agentic ecosystem using Google AI Stack, hosted by Google Developer Group's Fremont. So, I'm really excited to see such a strong interest from developers, AI enthusiasts. We got around like almost 200 registrations. And thank you so much for your time. For As I said, for those joining us for the first time, GDG Fremont is a community focused on learning, collaborating, and helping developers stay ahead with emerging technologies across AI, Google, cloud, mobile, web, and more technologies as they come up. So thank you again for all spending your time with us today on a Sunday, on a calm Sunday. So if you are joining this event, but you have not joined as a member, please go ahead and become a member. As I said, this is at no cost for you. Um, I'm pasting the link in the chat. Today's topic is especially exciting because we are moving beyond single AI prompts and isolated models into the world of multi-agent systems where intelligent agents collaborate, reason, orchestrate tasks, and build truly powerful workflows using the Google AI ecosystem. And to guide us through this session, we have an incredible speaker with us today, Karthik Devasari. Thank you so much, Karthik, for joining us. I will do a short description, introduction about him. Karthik is a customer engineer lead by profession and a technology advocate by passion, and he is recognized as a Google developer expert for Google Cloud and also a Google Cloud champion innovator. He is a six-time Google Cloud certified professional and works closely with enterprise pre-sales and delivery teams on generative AI and Google Cloud solutions. So, beyond his professional work, Karthik has made a huge impact in the developer ecosystem, and he runs Google developer groups for cloud professionals and served as a Google DSC lead. And yeah, he has also been a machine learning facilitator for Google AI's Explore machine learning program. So today he'll be sharing insights into building a multi-agentic ecosystem using the Google AI stack, and also including practical approaches, architectural thinking, and how developers can start building intelligent AI native applications. Before I'm calling Karthik to the stage. I have a couple of quick notes to start with. So please use the chat for questions throughout the session. At the end of the session, we'll try to reserve some time for Q&A. And also, if you enjoy the session, don't forget to connect with the community and share your feedback after the event. And the most important thing, at the end of the session, you will receive a post feedback form. Please don't forget to let us know your thoughts, the topics you would like to see us cover in the future. And at the end of the session, we will be sharing the code lab for today's session, and you can do it in your own pace. So this is all for me. I will invite Karthik to the stage. Karthik, this is all yours.
Sure. Thank you. Thank you so much, Buddhi and the GDG Fremont team for having me. Really excited to be speaking about the multi-agentic ecosystem, how it works, all the AI tools. Really excited. Thank you so much. And hello to all the participants in the chat. I see few folks joining in from different countries as well. Really excited to meet all of you virtually and present more about the Google Stack.
Yes.
Right, so I'm going to start by sharing my screen. Okay, just a quick check with the if I'm audible, visible perfectly.
Uh, yes. I think it's the same for the participants as well.
Okay, awesome. Thank you. So, building a multi-agentic ecosystem using the Google AI stack, using Gemini, Using Google Cloud is something that I'll be talking about today. And again, thanks, Buddhi, for the introduction. Just to share a few more details in simple words, right? What I do is that I lead the Google AI and Google Cloud Solutions Engineering Charter at Persistent. So during the weekdays, I would work with all the North America enterprise large customers, helping them use the Google AI stack, the Google Cloud stack to solve their business problems. And during the weekends, I love to speak at different events, mentor people, uh, and share more about whatever that I've been learning on the Google AI stack, on the Google Cloud stack. So that's how my week looks like. Uh, while I've been part of for expert program, I've been mentoring startups, sort of for startups program as well. In case if you're building, in case you need something on the tech side, if you're using cloud or AI stack, and if you need help, we'll be really happy to help on that front too. All right. Uh, Before we begin, I do have a few questions for all of you. So let's look at if you can drop your notes in the chat, that would be helpful. So how many of you have worked on web, mobile, data, cloud technologies? What's your tech stack? What sort of developer are you? If you can put in the chat, that would be helpful. Okay. Okay. I see web developers, I see full stack, I see cloud, multi-cloud people. Okay. Okay. Data and cloud, front end. Okay. Snowflake, full stack. And it's absolutely okay if you have not done any of these as well. Today, AI has changed how how you build. So it's not mandatory that you should have worked on these things. Okay, full stack front end. Awesome. How many of you have used Google Cloud or Firebase? Thanks for sharing all of that. That really helps. The audience, people coming in from all different locations or different backgrounds, it really helps to shape the presentation today. When we talk about what are AI agents, right? There's a lot of buzz going around these days that everybody's building AI agents. We are in the world of AI agents, but what they are, right? So let's look at that. So AI agents, when you see, right, they are more like the next frontier of software, right? Today, we are not just talking about AI that really sort of assist, but this is AI which acts on your behalf, right? So we are seeing the rise of AI agents where sophisticated systems that can perform complex tasks with like minimal human intervention. So if you see, there are like four key features components, right? One of them is autonomous action. So these agents demonstrate autonomous action. They can independently, execute tasks, workflows without human intervention as well, as you design your workflows. Second is reasoning and plan, right? So these agents, right, they leverage reasoning and planning using advanced AI models, using pro models, using reasoning focused, thinking focused models. They can make informed decisions and adopt to like changing environments as well, much like how we as human would do. Continuous learning, right? So they also engage in continuous learning as well. So when you design your agents, when you build your agents, you should have your agents built it in such a way that they also learn from experience. They refine their strategies, they refine their thinking plans, and improve their performance over time, right? So they become more effective with each interaction. And lastly, multi-agent collaboration, right? So think about this in a way, think about this in a way, think about this in a world where we have, multi-agents in our ecosystem, and these agents have become more collaborative. These agents can talk to each other, right? Like a team of experts, like a team of different personas, they can work together to achieve complex goals, right? And this unlocks like new levels of complexity and efficiency. Think about this in a way that if you are in a team right now, you would have a project manager, you would have a front end developer, you would have a back end developer, you would have a cloud engineer, for an example. Similarly, you can build agents based on these personas as well. So there could be an agent which is going to help you do all the project planning, estimations, and things of that sort, which is connected with different platforms. There could be an agent which really helps you from for the front end development. There could be an agent which really helps you do the back end cloud engineering stuff. So that's the world we are in. So and when you think about this, right, some of these are some of the key trends which are driving this transformation. So when you think about multimodal, AI is sort of not limited to text right now. We can now interact with images, videos, multimodal data, making our interactions more richer, more intuitive. When you talk about agentic workflows, and we are in free mode, we have seen way more, right? So AI is becoming more autonomous and capable, right? We are seeing the rise of agents that can reason, plan, adapt, and transform how we sort of work and collaborate. Third is knowledge frontier, right? So if you think about this, right, AI is redefining how we access and interact with information. If you had looked at the Google I/O keynote, right, there was this mention about Gemini Spark, right? So how it really helps you perform tasks, how it really helps you be more productive, right? So if you think about this, right, it's breaking down knowledge silos, interacting with multiple different platforms, and empowering users, empowering personas with insights like never before, right? So this is a truly exciting time to be working with AI, and really happy to talk about this. So when you talk about AI agents, right, and it's not that old, right? So we have been building AI agents, AI workflows, agentic workflows since a while now. And while we term it as agents, but it has been a journey, right? If you think about this, right, we started with LLM, right? So there's a large language model. We would prompt that model, and that would give an answer, and we would use that answer, right? Then came evolution where we actually started bringing our own data. So there's something called RAG, retrieval augmented generation RAG. So we use RAG to retrieve facts from data sources. It could be Google search, it could be your enterprise data, things of that sort, and stuff all of that data along with our prompt, so that we can get answers based on our private data. Then a feature of submodels called function calling that allowed LLMs to figure out what APIs to call with the right arguments and to execute them. Right. This is where we introduce tools which helped our sort of agentic ecosystem. Then, while we did this, we added reasoning loop as well. So, as you think about this, right, as our applications, as our use cases become more complex, we started adding reasoning loops as well to determine if we understand the user's intent. It builds a plan, it reviews that plan, it reviews the right tool choice, and all before sending the response to the user, right? So we are sort of in this sort of world, right, where we build agents with focusing on reasoning. And now that you see, we have multiple agents talking to each other, specialized to tools, specialized to different domains, specialized for processes. So when I talk about agents, I think about AI and I think about agents as in two different categories. One is AI for business problems. So how I can use AI agents to solve a finance problem, to solve a healthcare problem, to solve a supply chain problem. to solve a retail problem. So I think from AI for business perspective, and then second is how I can use AI agents for engineering perspective. And engineering perspective includes all things about your coding, right? So how you can use AI agents to automate some of your workflows, automate some of your engineering processes, where it's about data cleaning, let's say data quality, if it's about testing, for an example. And all of these functionalities is where you can also use leverage AI. So when I think about I think about two different categories: AI for business, it could be, or it could be AI for engineering. So while we did talk about this, right, building an agentic solution needs a lot of components. While we have been vibe coding, we have been building a lot of applications with prompts and with tools. There are tons of things that you should be ideally thinking about when you want to build your applications for production. And these are much more than a large language model. So when you think about building an AI agent, right, you have to think about the right context management, when to choose the right model. So when to choose which model, right? So if there's a use case where you want to just summarize the answers, if it's something that you want to super quick, you should choose more like a flash model. And if you have a use case where you really want to reason, you want to think, you want to plan, that is where you should use a pro sort of a model, right? So there are multiple different things that you should be thinking about before you move your application to production. And while you think about all things about building AI agents on this solution, there are also solution building blocks as well, right? So how when you think about this, right, you should also be thinking about your user interface, your monitoring, logging. How What do you think about security and authentication when you roll this out to your users? You should also be thinking about the safety filters and guardrails as well, right? So that your application, your AI agents are not misused by people, right? So these are some of the things that you should be ideally thinking about, uh, you know, when you want to build your applications for scale and for production. Now, when we talk about building an AI agent, right, we are going to talk about ADK. So ADK is the SDK launched by Google called the Agent Development Kit that really helps you build AI agents on the Google stack. So before we look at ADK, right, let's also take a quick look at what are some of the components of an AI agent, right? So if you look at it, right, an AI agent is a technique to give large language models access to tools like your APIs, your data, or it could be even other agents as well. Now we configure this agent with natural language instructions and examples. Then we give the models access to different type of memory like session history, user profile, it could be task profile, it could be data related to your sessions when you think about launching these agents. And you can also augment it with different task decomposition, planner services, things of that sort. And now you have an AI agent. So if you think about it, right, there are four key components: models, so choosing the right models; tools, which is going to help you fetch data, perform action, anything that has to do with external systems. Third is your orchestration layer. So think about how you sort of manage your sessions, manage your memory, manage your state, things of that sort. Because once you build your AI agents, you roll this out, right? You need proper consistent memory management, session management, things of that sort. So orchestration layer is also something which you should be really think up which you should really think about when you build your AI agents. And last but not the least, the runtime, right? So runtime is where your AI agents are going to be executed. So think about Cloud Run, for an example, or Agent Engine. These are some really easy to use uh, runtime services on GCP. These are also serverless, and I'm going to talk a bit about more as well on this. And when you try to think, right, there is a line graph, line chain. We can also do it on ourself as well, right? So sort of why ADK. So this is one of the comparison sort of a slide which showcases that, if you want to do similar sort of a thing, right? Uh, for each of the library, for each of the SDK, we have to write different sort of code. If you look at ADK, that is more of a agent framework, right, which helps you sort of orchestrate agents. When you talk about LangGraph, it's more of a low level orchestration framework. And when you think about LangChain, that's a really low level LLM framework. So with time, we do start from low level languages. There's a time when we started with that, but then slowly, eventually, we move to higher level languages. So similarly, that's sort of an approach here. Any questions? Okay, all right. In case if you have any questions, please do put it in the chat, and then we can have questions at the end of the presentation. All right. So when we talk about agents, right? ADK agents. So when you talk about agents, right? This is how the architecture looks like for any agent. If you see, right? So there are models. There's a base agent. So when you think about base agent, this is how each and every agent would have like a name. For an example, the way we used to have business cards, these agents also have uh, business cards, more like agent cards, right? And these agent cards would have a name of that agent. It would have let's say a model, so you choose your model as well. It could be Gemini model, it could be Claude, it could be Llama, it could be OpenAI, it could be any models. And then for these models as well, there are different versions. So you should think when to use which model based on your use case. At times, you should use a flash model if you want something super quick, for an example, and if it's not super complex. If it's something super complex, then you should use a reasoning model. Then you provide all the instruction. This could be your prompts, that this could be your agent skills. So all of that would be part of your instructions. When you talk about tools, you can have tools like Google search. So let's say when you want your AI agents to be able to talk to the Google search data, you can use Google search grounding. You can also have RAG as a tool as well. Let's say if you want to expose your private data to your agent, so you can build MCP for that. There could also be custom tools as well. When you think about video, audio, all this is how your agents can also be interfaced, right? So you can also have an agent where you trigger that agent through voice. You can trigger that agent, using, let's say, using voice, using live sort of conversation, things of that sort. Uh, from a data perspective, from a custom rack perspective, you can have different multimodal data, right? So you can have videos, you can have your cloud SQL, for an example, SQL databases. You can have your files, your PDFs, things of that. So you can sort of perform RAG on top of that. And last but not the least, agents, right? So while we looked at the architecture of a single base agent, this agent can also talk to multiple different agents which are specialized for their purposes, right? So that is where this agent card would help all these multi agents talk to each other, interact with each other using the agent card. So that's a we'll take a quick look at what A2A is as well at the end of the session, but this is just explain the overall architecture. And uh, sometimes people do have questions. What is RAG? Why do we have to build RAG, right? So the problem here is that LLMs will not have your business proprietary knowledge, right? And they would not have access to your data by default. They would not be trained on your data, right? Second is they also don't have real-time information. So these are models which have been trained on a specific set of data, and they do not have access to live data by default. So that is where you sort of perform RAG. Third is it also gets trickier when, let's say, if you wanna understand where this answer is coming from, right? So that is where RAG is also very helpful. It gives you that this answer is coming from the right resources, and it can also give you citations as well, so that you can see that okay, this answer is coming from XYZ PDF, section 2.5.3, page number 53, for an example, right? So that is why we sort of build our agents equipped with RAG. All right. When we talk about agentic AI on Google Cloud, Google Cloud is a completely full stack AI company. So when you look at it, it again starts from all different layers, right? So uh, when you think about user interfaces, right, you could have Google Cloud agents. There is Gemini Enterprise, Vertex AI Search for commerce, even Gemini Enterprise for customer experience, which was earlier known as Customer Engagement Suite. These are like multiple different user interfaces through which you can interact with these agents. And then there's Vertex AI, right? So Vertex AI or Gemini Enterprise Agent Platform, that is the platform which really helps you build agents to build AI ecosystem, right? So you start with Model Garden, right? So Model Garden is one of those offering from Google Cloud, using which you can interact with any large language models, right? So you could use Gemini models, you could use the Gen Media models, so all models like Nano Banana, VO models, probably Gemini Omni as well. And then third is partner models, right? So you can use partner models like Claude models from Anthropic, or you could use Llama models from Meta. So all these are partner models that you can also use on Vertex AI to build your applications. You can also use any open source models that are hosted on Hugging Face as well. So if you like any models from there, you can use those models too. Then second is building, deploying, and managing models, right? So even if you want to fine tune your SLM, you can also do that on top of on top of the Vertex AI stack. It helps you do your fine tuning as well. Uh, Third is when you think about enterprise and data and tools, right? There are multiple different really important components that they offer. So one of them is grounding RAG based on the Google web search data. You could also ground based on the maps data. And third is you can ground based on your private enterprise data. So when I say I wanna build an agent, for an example, which should ideally go and look at some of the Google open data, right? It should also look at the Google Maps data, and help me with the response. So all of that is sort of built in as well, so you don't have to really have custom connectors and things of that sort. Third is enterprise data. So when you think about enterprise data, you could have structured data, you could have unstructured data. Your structured data could be sitting somewhere in, let's say, Cloud SQL or BigQuery or Spanner. So your AI agents can talk to your structured data using the MCP toolbox. And even if you have unstructured data, you can have a sort of RAG built on top of your Google Cloud Storage or file store, for an example, for your agents to be equipped with that data. There's also conversational analytics API. So if you want to have a chat on top of your data warehouse, for an example, you can also do that using the conversational analytics API launched by Google. And there are again tons of connectors, integrations, all of that is sort of available. There are also platforms called Agent Designer, Agent Builder, which helps you build agents without writing any code using the agent platform itself. So that is also there. And once you have built all of your agents, right, you can have your agents talking to other agents using the A2A, agent to agent protocol. There's also AP2. So AP2 is the payments protocol. So let's say if you want your agent to perform some sort of shopping and make payment on your behalf, Google has also launched the AP2 protocol in that front. And while you do all of this, one of those things which is that when you think about building agents using ADK and the Google AI stack, uh, in let's say, and then you have some agents built using LangChain, for an example. These agents can also talk to each other using the A2A protocol. So it is not a mandate that every agent who is built with Google AI Stack has to be talking to only a Google AI Stack agent. These agents can talk to any agent can talk to any agent using the A2A mechanism. A2A again uses the agent card, which is more like a business card exchange that we used to do back in the days. Last but not the least, the build stack, right? So you can use ADK to have to build agents. Once you do that, you deploy your agents on agent engine. This is a managed runtime. This agent engine is a serverless offering which helps you deploy your agents very easily. It takes care of session. You can also have memory bank integrated in your agent engine as well, so that you don't have to do all of that by yourself. And there is also code execution and computer usage features as well as part of agent engine. So think about this in a way that where you want your AI agents to also perform some sort of code execution and then return your answers. Agent engine also has that mechanism which helps you do that as well across different sessions, right? So if you try to do that manually on a VM, it's going to be quite tricky. But for an example, for that sort of an example, agent engine is going to be really helpful to do that same thing. And lastly, governing and orchestrating is really important as well, right? So when you think about this, right, when you think about multi agents, you should have all your agents listed as part of your agent registry. So it really helps you look at, let's say, when I have all of my team members building agents, I can go to I can go to the registry. I can look at what all agents that they have built, what all tools that are there. There's also model registry, right? For an example, then there is identity. So you can have granular access control levels for your agents. You don't want all of your agents to be able to perform all operations, all right operations, right? So using the agent identity, you can manage, control, and govern that I want some of these agents to be read only, and then I want some of these agents to be able to perform some sort of an action on my database, for an example, on my cloud, for an example, things of that sort. So agent identity is also one of those really important things. Lastly, the last two stacks, right? If you see security command center, again, very interesting thing if you are into cybersecurity, how you can sort of have entire end-to-end AI tracing from a cybersecurity perspective, and you can also use Wiz. Uh, so if you want to look at this, there's a really interesting demo that that was there on the Google Cloud Next keynote, the developer keynote. It is one of those really good examples which showcases that how you build agents, multi agents, and then have your agent super secure with the Wiz platform. Lastly, the infrastructure layer. So when you think about AI, if you want to do your things on your own, you can also use the GPUs and TPUs offered as part of the cloud platform. Now, TPUs are also enabled with Cloud Run, so you can also have serverless TPUs as well. When and last thing, when you think about data, think about this in a way that you could have your data warehouse in BigQuery. You can use Apache Spark Beam for an example, data flow for on GCP. With that, you can also have your knowledge catalog, data catalog on Dataplex, the knowledge catalog platform. So all of that is something that you should be thinking about. You should use when you think about building your agents for scale, building your agents for production. So while we started with a L100 session on what are AI agents, this is where it helps you understand what are some of the end-to-end things that you should be thinking about when you want to roll these out agents to thousands and millions of your users. So if there are any questions that you have, please put in the chat and we'll address at the end of session.
Yes, Karthik, we have a couple of questions accumulated so far about like what does low level mean? And Vikram asks, when is an agent called sub-agent? Are agents not peers? What is the difference between an agent and sub-agent? And Atul is asking, can you share the link of Next? And Damu is asking, can you share the security related link? So as you go on, if you can address these questions, um, we can do a proper flow.
Yeah, I can share the link to the slide deck. The slide deck will be shared at the end of the presentation. For the security presentation, allow me some time, and post we are done with the presentation, I will share that link as well for the next security presentation. Yeah, to Vikram's question, when you think about an AI agent, right? So think about this in a way that when you want to build your agents, let's say when you want to build a agent for a very specific finance trading purpose, for an example. So you have your agent, you have your agent for that entire purpose, and then for each agent use case, you have a root agent by default, right? And this root agent is going to be more of an orchestrator, and then for each and every specific task, or for a specific purpose, you should have sub agents. So these are some agents which will help you look at some of those things. Let me see if I have that slide. Right. So this is one of the slides, right? So when you think about this, right, you can have agents built in a sequential manner. You can have parallel agents as well, and you can have loop-based agents as well. So when you think about this, right, you have your base agent, you have your sub agents as part of your agent, and you can have a sequential workflow where I want to build this workflow, let's say, where I want my agent one to perform some task. Once it performs some task, I want the output of that agent one to be passed on to the second agent so that second agent can perform its task, and things of that sort. So that is where you use a sequential agent architectural pattern. Then one of those examples is a parallel agent as well. So for an example, I want to do that. I want to build AI agents where I start with something. My user starts with a prompt, and then I want, let's say, one agent to be researching on Google search data, for an example. Parallelly, I want another agent to search on my private structured data. And third agent, I want it to be researching on my unstructured private data, for an example. And at the end of all three, you have an aggregator sort of a thing. You have an aggregator sort of a design where it takes the output of all these three parallel agents, and summarizes the response and sends it to the user. that sort of a thing. Third could be a loop agent architectural pattern as well. So where, let's say, you want uh, your agents to be thinking and reasoning and making a more of a critic. For an example, you have one agent which creates the plan, for an example, which reasons and thinks and creates the plan. Then you want another agent, which is again a expert agent, and you want that agent to validate and challenge that plan, so that these agents can talk to each other, have critics, for an example, and then you have the best output. And you can have loop based on a few counts as well. There's also a really good code lab which is going to help you understand more about this, and I will share that at the end of the presentation. So really cool stuff on that too, so I will share on that too. Lastly, you can have a hierarchical routing as well. So let's say you have multiple different sub agents sort of defined. You can have a router sort of a thing where LLM takes the call on when to call which agent, for an example, for what purpose, and then it does that workflow. So that's also one of those things, one of those architectural patterns that you can use while building your agents. Okay, all right. I will talk again a little bit about how agent engine sort of works, right? So if you see here, right, it also helps you understand and visualize how these works, right? So you define an agent in a agent framework. It could be ADK, it could be LangGraph, LangChain, Llama Index, Crew AI, any Python sort of framework, any agent frameworks uh, using which you can build agents. You can deploy these agents to agent engine. So this gives you memory stores, manage session, memory, code execution, sandbox environment. So all of that is sort of taken care of. You can also have Terraform integrated. So when if you want to do that sort of automation on agent engine, you can also do that. While you do that, while your agents are deployed on agent engine, they are covered by the enterprise, like Google Cloud Enterprise observability stack, right? So you get cloud tracing, cloud logging, cloud monitoring enabled on these agents. So whenever somebody makes a call, you all get all the traces, logging, monitoring stuff, and you can build all of that observability stack on your agents using that native integration. Your agents deployed on agent engine, they can be used on any platform. So you can have it on a custom front end, you can have it as a API, you can have it as a starter pack. You can use your AI agents deployed on agent engine anyway, sort of where you like. Then you can also register these agents on agent space or Gemini Enterprise platform as well. So if you've been using Gemini Enterprise, you can also do that too. On the right hand side, you see that when you think about again building these agents can be shared using and can talk to all of your agents through the A2A protocol. These agents can be equipped with tools. This could be built-in tools like Google Search, Google Maps, sort of an MCP. You can also have custom tools. You can also have the Google Cloud tools, right? So Google Cloud has also launched MCPs for Knowledge Hub, for Cloud Run, for some like MCP for their databases as well. So you can leverage all of that. And then third is you can also have your own MCP integration as well. So let's say if there's a API server, which let's say there's a API server which has got 50 APIs, and it's been there since years and years, and now you want to expose all these APIs to your agents. You can build a MCP server on top of these, let's say 50 APIs, and equip your agents with that MCP server. So that thing works as well. You can build that too. So in models, right? So you could use Gemini model, you could use any models from the model garden. It could be Claude, it could be Llama, And you can also have your fine-tuned SLM models as well, connected to your agent framework. So that works too. So again, any questions if you have on agent engine, we can talk about that. Lastly, again, quick thing on A2A, right? So when we think about A2A, it was innovated, launched by Google. This protocol was launched by Google, and then everybody in the industry sort of adopted to this protocol, and now this protocol has been donated to the Linux Foundation, and this has truly become a new standard for all the agent-to-agent collaboration. So when you think about this, this is equipped with all the enterprise, mind use in mind as well. So this has all the security governance sort of mechanisms as well. When you think about your agent interaction between these two things, this is also supported by the industry standards as well. So your agents could be talking in a HTTP, or as a SSC or a JSON RPC sort of a communication system as well. And again, this has partnered with all the organizations and in the industry. So even if you have been building, let's say, agents with LangChain or LangGraph, for an example, right? Those LangGraph agents can also talk to your ADK agents and perform anything that is needed. So that is there too. And how do these again agents communicate? Uh, and how do agents know about other agents, right? So similarly, the way we used to have business cards, right? So these agents have agent card, which has all the details about the agent. So the name, the description, it gives you more like details about like entire details about this agent. Where is this agent hosted, how to call this agent, what protocol should I be using to call this agent, uh, is there a security mechanism enabled on this agent? If that is enabled, what sort of token does it use to to securely authenticate between these two agents? So all of those details are defined in a JSON format, and these agents sort of talk to each other using that protocol. So that's on that. And while we talk about A2A, I've also had too many questions on, should I use A2A or should I use MCP, right? So this also really helps you understand that what is the difference, right? So A2A and MCP complement with each other, right? So MCP is more like providing access to your data sources and tools to your agents. That is where the MCP protocol, the model context protocol, is used, basically providing your large language model with all the data. And A2A is where you have multiple different agents talking to each other. So this is where, let's say, you think about this in a way where you have built agent A, for an example, and you have built agent B. So agent A is equipped with multiple different MCP integrations. So you can have different data sources integrated with your agent A. This agent A is talking to these data sources using the MCP integration. Similarly, you have agent B. Agent B is also equipped to multiple different data sources using the MCP integration. And while you have these two agents, these agents can also talk to each other using the A2A protocol, right? So this is how A2A and MCP differ from each other. So even if you have any questions on A2 MCP, love to take that. All right. And lastly, I want to share a few really good code labs with all of you. Uh, this is one of those really good code labs which will sort of help you get started with building your first AI companion with ADK, with the anti-gravity CLI. So if you want to build your agents, if you quickly want to get started with building your agents, if you don't want to get into the really nitty-gritties of writing code, this helps you to build it super simple in a super simple format using the anti-gravity CLI. And there's also this code lab, which is a little bit complex code lab, but again, this is also one of those code labs which I really like, which is going to help you understand how these agents work, how ADK agents work, how these agents sort of talk to each other. uh, again, all of these details will also be shared along with the slide deck. But these are some of the really good code labs which will help you get some hands-on experience on building agents. Yep. So Bhuti will share all the code labs with the participants, and uh, we,
Yes.
get started. So thank you. Thanks for tuning in. I know it's been a Sunday, and you've had an hour-long session, virtual, but thank you so much. It was so much fun, and I'll be happy to have any of the questions uh, that you have.
Thank you so much, Karthik. So I thought we can address some questions posted. You may already have covered this in during the presentation, but in case if you didn't, I will go through these questions again. So Venugopal asks how error handling works in this agent orchestration. One of the two error, how this works in parallel agent and routing mechanism.
Okay. So, okay, let me repeat that question and sort of rephrase this question.
Mhm.
When I say how error handling works in this agent orchestration, one of the tool error, it could be one of the tool error, how this works in parallel agent and routing mechanism. Okay. I think there are multiple different things. It's a super complex question again. So I'll use my pro model brain and try to answer this question. So, uh, how error handling works in agent orchestration, right? Think about this in a way that when you build agents and deploy agents onto agent engine, for an example, you get the end-to-end traceability, observability, logging whenever there is an error, right? So if you have your agents deployed, you can quickly take a look that what the error is from your native Google Cloud logging itself. So you can do that. You can also have errors created on top of that as well, right? Based on the monitoring platform. So that also helps. So first was identifying and being informed on if there is an error. So we covered that part. Second is what if a tool error happens, or how this works in parallel agents. Again, all of that is something that you can inspect using the observability stack. That is it, right? There's no simple or one single answer on how to do entire thing. You inspect and you do that. It could be an authentication error, it could be a timeout error, things of that sort, and you sort of fix it and you do that. uh, how this works in parallel agent routing, again, probably the same thing, right? So inspecting is something that you can do whenever you also build your agents using ADK. And when you run ADK web, you can actually have a look at how the entire architecture looks like, along with all the tools. And you can actually inspect on the left hand side that what was the data being passed, what were the responses that you got from your tool calling, things of that sort. And that's how you can sort of inspect and perform action, inspect and make changes to your agents. So that's that, yeah.
Thank you very much, Karthik, and thank you, Gopal, for the question too. So next, Vikram asks, is it fair to say agents just add more context to LLM to provide better responses, whether calling tools or getting some data, as one agent doing everything is not manageable? So breaking up work into manageable chunks and organized sequential parallel, etc., is just that management. And I think the question is broken down into pieces, but Can you provide a general answer for this question, Karthik?
Yeah. So when I think about agents, right, think about this in a way that, let's say 2 years back, for an example, right, or a year back, when we wanted to build something, let's say I want to build a travel management portal, for an example, I would not start by defining how many functions will I create as part of the code, right? I start by writing the code and then sort of extracting functions, extracting the common utility functions, then having specialized functions, for an example, right? And these are functions, right? Think about this a year back or 2 years back. This is how we used to write code in Python and Java and JavaScript and things of that sort, right? Similarly, I think about these agents, right? So when you have some sort of common functionalities, I see that these could be extracted as a sub agent, and I can have these common agents which can be leveraged across the cycle. And then while I have few common agents, I also think that we should also have specialized agents, right? So specialized agents for a very specific special purpose. So they are equipped to do exactly what they are tasked to. So having this sort of a thing is something which really helps you have uh, a really classic example of when to when to build an agent, or when to create a function, when to extract a function. And yeah, all these functions, all these agents can talk to each other. Similarly, how functions can also can be called across different things.
Thank you, Karthik, and thank you, Vikram, for the question. And from Dina, we have two questions. With A2A, is it possible to implement multi-agent orchestration? That's question number one. And later, he asks, uh, sorry, is it possible to implement resilient ADK agents when the code or tools for it failed?
Right.
Yeah.
So I'll start with first, right? So first is when I want to build an multi-agent orchestration or ecosystem, we use A2A, right? That is the industry standard. That is the protocol when your agent A wants to talk to your agent B. So that is the protocol that we sort of use. And second question was that how to implement resilient ADK agents when the again, when you build your ADK agents, you can have while you build that, you can have these ADK agents deployed, let's say as ADK web, for an example. When you build these agents, and you can look at the tool calling, you can look at what data was passed, what parameters were passed to these tools, and you can also see that what tools are what responses coming from these tools as well. And while you do that, you can also have uh, in your code itself, you can have a fallback mechanism that if your tool fails, for an example, it should respond with xyz response, right? So your workflow will not break, right? So again, when you think about again, I think these are really good questions, right? A lot of us have been vibe coding and building applications, but when you think about rolling this into production, these are some of the really good questions that you should be thinking about when you want to roll this out. So thanks for all the questions.
Yeah, Karthik, we have a final question. Ramohan asks, what are costs of hosting custom agents? Is there a fee? You are tired.
Right. So when you think about Cloud Run, for an example, to host your agent, Cloud Run is a serverless offering similar to Agent Engine. Cloud Run has a really huge free tier, to be honest. Even if you have 2 million calls coming into your Cloud Run, uh, your agent hosted in Cloud Run, for an example, you will not be charged $1 for a month. So even if you have 2 million calls to per month to your agent, you will not be charged. It's pretty cheap in that sense. And even Agent Engine, I believe it has a free tier as well. I am not super sure, but there is a website which will, if you search for like Google Cloud free tier, it's gonna help you with the whole list of what all things are included.
Okay, Karthik, thank you so much. Thank you, Ramohan, for the question. And thank you so much, Karthik, for the amazing presentation, amazing session today. I think our participants learned a lot about building multi-agentic systems using Google AI. Another thing is we need to remind our participants to complete the code labs. The links are shared in the chat. So when you complete these code labs, you will be able to earn a badge as a complete like learning badge in your Google developer profile. So it will be showcasing in your profile too. So please don't forget to go through the code labs and try to complete them in your own pace with the lesson, like with the stuff you learned today. And another thing is when you around, I think after this session around 11:25, you will receive a post event feedback form to be filled. So we are really interested and would love to hear back from you. What do you think about today's session, and what are your interests in our future sessions? And please don't forget to give your feedbacks after the event too. So we'll keep in touch, and please join our community. We will be organizing events as this in the future too. And please become a member and know whenever we are posting events as this. So thank you very much for this awesome day. Hope seeing you in the future very soon. And thank you again so much, Karthik. We will have you again in one of our GDG Fremont events in the future.
For sure. Thank you so much, the team. Thank you so much, all the participants, for having me over today. It's really glad to be talking about the entire stack. Thanks.
Yes.
Love to see
Thank
you.
you. Thank you very much. Bye bye.
Bye.